Hello everyone! I've decided to try and beat Minecraft from a computer terminal. As I create the world and initialize the challenge, I'll explain my rules. My goal is to beat Minecraft entirely through typing commands and writing scripts for devices called turtles. Turtles are robots from a mod called Computercraft that can do most things players can, such as move, mine and place blocks, kill mobs, till farmland, and more. But what exactly are my challenge rules? They are: first and foremost, if the computer can do something, it must do it. I am not allowed to break or place blocks, view inventories, hurt mobs, trade with villagers, or do just about anything else. What I can do is serve as a supplementary inventory to my turtles and issue them commands. Just to warn you, however, there are a couple of things I do by accident in this episode that violate this rule. When they come up, I'll explain more about them and how I plan to avoid them in the future. Second, I'm allowed to install additional mods that either serve as general utility or expand my turtle's capabilities. Right now, I have 3. 2 are add-ons that allow me to use turtles to breed animals, enchant items, trade with villagers, and more. The third is just enough items, which lets me view the recipes for vanilla and modded items alike. In the next episode, I plan on adding a camera mod to make the playthrough more fun to watch for you. The reason I allow these mods is because the point isn't for me to work with limited game mechanics, it's for me to learn to script everything I can already do in Minecraft using Lua. Third, I am allowed to use artificial intelligence for educational purposes only. I have already used ChatGPT extensively in combination with the Lua manual in order to answer my questions about Lua and the embedded Computercraft environment. I haven't used it and won't use it to write my programs for me. That's no fun for either me or you viewers. Finally, I start the game with 1 mining crafty turtle and 1 piece of coal, the bare minimum to get started in a run like this. Just like in real life, computers in Minecraft require energy to function. In Minecraft, however, they only consume energy when they move. 1 piece of coal is enough to allow this turtle to move 80 blocks, which is enough to fell a few trees for more fuel. I'm allowed to place this turtle down once. After that, I can never place another block. One more thing. You may have noticed that I started this run with cheats on and with the difficulty on normal. The former is to give myself my starting items and, if needed, resolve glitches later on, and the latter is to prevent me from dying excessively, seeing as I have no way of defending myself early game. With that, my adventure starts. My first objective is to find somewhere with trees. It's almost as if the game knew that this was what I was going to do, so it spawns me in the middle of a vast desert. Thanks, Minecraft. To add further insult to injury, the first thing I find on my way is a ruined nether portal right next to a desert temple. I'd take the loot, but that would require me to place down my turtle, which I refuse to do without access to renewable fuel. I screenshotted their coordinates and moved on. In retrospect, computers in Minecraft can store text files just like real ones can, so I could have recorded these coordinates using my turtle. This meant taking this screenshot was illegal via my challenge's rule of if the computer can do it, it must do it. I've deleted the screenshot now, and if I need the treasure from here that badly, I can find it again. On my way, I take my first hit of damage in this world, from skill issue, otherwise known as falling. At this point, I have a lot of swimming to do, so with some editing magic, I'm there. Since it's still night, climbing directly onto the shore risks getting me seen by monsters. Instead, I place the turtle on the side of the coast and immediately start shortening some basic commands. You see, each turtle command is part of the Turtle API, which is a library of commands the turtles can do. All of these start with the word turtle and are followed by a dot and a word or two describing what the command does, along with some parentheses. This makes typing individual commands burdensome. However, I can shorten them by writing programs with short names that call each of these commands. For example, I can shorten turtle.forward, which moves the turtle forward, to just F. The interface I'm using to call these programs is called the shell. The shell is a command line computer interface. From here, I can create or delete files, run programs, transfer data, and more, much like the desktop on most real-world consumer computers, and exactly like the terminals used by real-world industrial servers. In this challenge, I'll use the shell to create, transfer, and modify programs that my turtle can use as instructions for what I want it to accomplish. When I want my turtle to do something, like with these shortened commands, I just have to type the appropriate program's name into the shell, like F. Soon I run into the first bug, or unintended software feature, of the run. I'm trying to make the turtle display its fuel level whenever I run a program named GFL, short for Get Fuel Level. However, when I run the program, nothing shows up. This is because the shell is not the only terminal inside my turtle. There is another. Whenever I type lua as a shell command, it brings me to this other terminal. The difference between them is that in the first terminal I use general purpose shell commands, and in the second terminal I use lua commands. The turtle.getFuelLevel is a lua command that returns a number which will be automatically printed in the lua terminal. However, the shell will not automatically print the results of commands that I call on it. This means that I have to tell it to print or display the result explicitly. At least that one was an easy fix. Naturally, I immediately run into another programming problem. I want a program that can make selecting slots in Turtle's inventories quicker. For those unfamiliar with Turtles, they can only use items in any capacity if the slot of their inventory containing that item is selected. For example, if I want my turtle to place down some dirt, I would need to select this slot right here. However, I need a way to tell the corresponding lua command, turtle.select, which inventory slot I want. I can do this using an argument, which is the input for a command. In this case, I need to provide a number from 1 to 16 as an input since the turtle has 16 inventory slots. At the time I made the recording, I was convinced programs could not be called with arguments and felt stuck. I have since learned that programs can be called with arguments and that those arguments can be accessed by extracting them from a special value named ... I'll be using this in future episodes. For now, I put off solving the problem entirely. When daylight comes and my manual commands are in decent shape, it's time to gather my first resource of the run: wood. Wood is critical to the success of this run because it can be smelted to yield charcoal, which can fuel my turtles. Additionally, it's an extremely common crafting reagent and a good building material, so long as I don't care about fireproofing. Next, I maneuver my turtle to the surface and position it at the base of a tree. It's time to write my first multi-step program of the run, the tree felling program. I don't know who originally came up with it, but it's not my original idea. It works like this. The turtle looks up to see if there are any blocks above it, and if there are, it digs above it and moves upward. If there are no blocks above it, it knows that it's reached the top of the tree, so it comes back down. This, of course, only works for completely straight trees, like small oak trees, spruce, birch, and small jungle trees. This program, simple though it is, teaches a concept used everywhere in programming: a while loop. A loop is a sequence of commands that repeats. A while loop repeats until some condition is met, or runs while the condition is not yet fulfilled. In this case, I use two. The first loop tells the turtle to dig and move up while there are still blocks there, and the second tells it to move down while there is nothing in the way. My next task is to craft a furnace to burn charcoal. To prepare for crafting, I empty my turtle's inventory of everything not used in the recipe. This is because any of the 4 continuous 3x3 squares in its inventory will work just like a crafting bench, and upon calling the function that crafts, the turtle will automatically detect which square is being used and craft the item. For this to work, a valid recipe must be present, so I can't afford to have junk in the way. Now I could do this manually, but I won't. I'll write another program instead. It will use 2 new programming devices. The first is a table, which I chose to call flist, or list of crafting components for our furnace. A table is a list, sort of like a grocery list or a roll call. Tables are useful for the same reason lists and spreadsheets are in real life. They can hold and organize many individual yet related pieces of information. Specifically, a table in Lua is a list of associations between keys and values. Keys are used to access values by citing the name of the table with the appropriate key as an argument. Tables are created using a set of curly brackets, and table values are assigned by setting them equal to something, like you see me doing here. This table, flist, uses numbers as both keys and values. All I'm trying to store in this table is whether the computer should place a piece of cobblestone in its nth inventory slot or not. The inventory slots proceed in English reading order from the top left corner to the bottom right, from 1 to 16. I want to place the cobblestone in a ring in the top left 3x3 box, so, as listed, slots 1 through 3, 5, 7, and 9 through 11 should all have cobblestone while the others shouldn't. If you're paying close attention, you might ask, what do you do for the other slots? Shouldn't they have a 0 or something? The answer is that tables in Lua already contain a value for every possible key the moment you create them. All these values are nil. Nil is not 0. It's a placeholder value that means nothing. So every inventory slot I want filled with cobblestone has a 1 in my table, while the rest are nil. This introduces the idea of types. In all programming languages, computers store information through variables, represented either by letters, like the famous X and Y from algebra, or by whole words and phrases like sum or cell1. These variables can store different types of information depending on their type, much like egg cartons hold eggs and milk jugs hold milk, but definitely not vice versa. In Lua, there are 8 types of values: number, nil, table, boolean, string, function, thread, and user data. So far, we've encountered numbers, nil, and tables. What about the rest? A Boolean value is either true or false and is used for checking conditions like with if or while. A string is a sequence of characters of any kind surrounded by quotation marks. A few examples are Minecraft, Minecraft, and 0. A function is a sequence of commands. Threads allow Lua to multitask, and personally I'm less sure about user data values. From what the manual says, it seems like they're used to interact with C, a lower level language. I don't know any more than that. The reason why types matter is because they're treated differently from one another. For example, if x equals 0 and y equals 1, then x plus y equals 1. But if x equals quote-unquote 0 and y equals quote-unquote 1, both strings, adding them will result in an error because Lua doesn't understand why you're adding words together. This sort of thing comes up all the time, including in this episode. Now back to the furnace program. With the table in place, the computer just goes through the numbers 1 through 16, checks the table to see if that slot should have cobblestone or not, and if it should, it places cobblestone there. Once all the cobblestone is in place, it crafts the item. Of course, I goof this up the first time and get the slots wrong. That's okay. Nothing works right the first time in programming. In the middle of this, it occurs to me that with my falling hunger shanks and half health, I'm probably going to die. I note my location in chat for later. As with the ruined portal and desert temple, I now realize this was a mistake. I should have created a text file in the turtle for that, or just committed it to memory. I'll do that next time. In fact, since computers can chat with the right upgrade, I really shouldn't be using the chat at all. After I edited the slots, the turtle crafts my very first furnace. Now, 33 minutes into the run, I can finally obtain charcoal. I spend the next few minutes maneuvering the turtle so I can place the furnace and smelt wood with it. Furnaces in Minecraft accept fuel from the sides and items from the top, so I have to move the turtle to both positions to properly set up my furnace. And presto! I get my first piece of charcoal. Every piece I get allows my turtle to move another 80 blocks, so this is a big win. Noting my success, Minecraft sends a creeper to congratulate me. Not wanting to party too hard just yet, I stay in my hole and direct my turtle to move beneath the furnace so it can pick up the charcoal. Except that I soft-locked myself, and we're not going to talk about this. Unfortunately, I still can't reach my turtle. As I said in-game, it's content time. If I can bait this creeper into blowing up the blocks surrounding my turtle, I can access it. I bait it over, and I blew it up early. Drat. However, with a well-placed jump, I can barely reach him, and that's good enough. After a quick refuel, I decide to dig out a staircase from the bottom of the hill to the top to make traversing slightly more comfortable. Then it's my favorite time. Tree cutting time! Despite being literally right above it, I somehow managed to lose track of my hovel. In response, I write a quick program that works similarly to the tree cutting program. It tells the turtle to dig a 1x3 tunnel until it doesn't detect a block in front of it. It works, but I'm a little too far down. That's alright though, as it's time to celebrate. I get to eat my first piece of food in this run. It's an apple, just one, but it's something. With my spirits high and my stomach full with seawater and wild apple, it's time to experiment. In order to write any function that allows the turtle to work autonomously, I need a way for the turtle to perceive what's around it. Not just that there is something, but what that something is. This is where the inspect function comes in. It looks at the block in front of the turtle and returns two values: a boolean stating whether it saw something or not, and a table describing what it saw if it saw something. To find out more about the function's output, I write the outputted table to a text file and take a look. It seems like two of its entries are other tables, but the middle entry, name, is exactly what I'm looking for. I can extract the block's name. This is huge. If I task my turtle with remembering the name it gets when inspecting a block, I can make it aware of its surroundings and have it respond accordingly. For example, I can keep it in a contained area, farm clay by waiting until mud is drained by dripstone, have it complete unfinished builds by keeping track of which blocks were already placed, farm trees by placing saplings in specific locations, have it avoid digging ores in a quarry if it doesn't have the right pickaxe, and so much more. Naturally, I demonstrate my newfound brilliance by falling down my hole. Ouch. Nonetheless, I carry on planting saplings and cutting wood to renew my supply of fuel. I further demonstrate my brilliance by soft-talking myself for the second time. I thought I could move the turtle in large stretches towards my cove, but I didn't think about how that would work with me on the ground and it in the air. Right. After a few jumps, I get it back, but I've got company. I try to maneuver my turtle underneath the water to avoid it, which works well until I run out of fuel. As I fiddle with it to refuel with it, I stop paying attention and drown. I thought the monsters would be eating me alive in this run, but no, it's environmental hazards instead. With my illicitly posted coordinates, I easily, yet tediously, make my way back. Do you remember how I thought that programs can't be called with arguments? Still convinced of this lie, I found a way around it. User input. In Lua, this is done with the command io.read. Whenever it's called, it provides a prompt for the program's user to enter a value. In this case, I just specify how many blocks forward I want my turtle to move. I put this knowledge to use by making a program that allows my turtle to move a specified number of blocks in a specified direction. This program works using the other kind of loop, a for loop. Technically, for loop is a kind of while loop, comment if you know why, but it's so useful that it gets its own name. You see, a for loop runs a set number of times. It keeps track of how far along it is through an iterator, or a value that usually starts at 1, then is incremented until it reaches its final value. In my case, I use the letter I for my iterator. I need a for loop here because I want my program to move the turtle a specified number of times. Turtles can only take one step at a time by default, so if I want to take, say, 10 steps, I can either write turtle.forward 10 times, or I can write a loop that goes from 1 to 10 and just call it once. For shorter processes, this difference doesn't matter much, but what if I wanted it to move 100 blocks, or 1,000, or more? For loops make this easy. Instead of testing my new movement function like I should have, I immediately set to work writing a function that can dig a box-shaped hole. I figured that having more space to live would be nice, and that construction on the surface would be much more difficult to program. There aren't any new central concepts in this program, so I'll explain something else while I work. Every time you see two dashes next to each other in my programs, like this, that means I've left a comment. A comment is a line or paragraph of text that doesn't run as code. This allows programmers to take notes that help themselves remember what different blocks of their code do and communicate those purposes clearly to their coworkers. Comments are, as far as I know, universal across all programming languages due to their utility. After 15 minutes, I begin testing my box digging program. It doesn't work on the first try, of course, so I spend a minute or two correcting its typos. After it runs, I realize that instead of digging underground, I had attempted to dig into the ocean. That wasn't going to pan out without a lot more programming, so I canceled the operation and turned my attention elsewhere. Since I was thinking about digging, I decided to edit my tunnel program. Before, the turtle would dig until it reached a gap. Now I think it will be more useful for me to tell the turtle how many blocks long the tunnel should be so it doesn't run too long and run out of fuel. At this point, I had a genius idea. What if I had one single program that could craft anything whatsoever? All I'd have to do is add the appropriate number of arrays and a little more code for item logistics, except that I wrote it off as a to-do list item and procrastinated it, just like testing my movement program. There was a more pressing issue. Trees needed to be chopped once again. That, and apparently debugging needed to happen. This is going to be a core part of my gameplay loop for the foreseeable future. This time, I had to specify that my select function recognized the number I entered as number, not as a string or something else. This is what I was referring to earlier with types. If the select function finds something in it that isn't of type number, it has no idea what to do, even if what it finds looks like a number to us. After a few minutes of that, it was finally time to test my movement program. It had typos, as expected, but worked fine after fixing them. Now it's time for me to work on the most critical project of the entire episode, building a dirt platform. You think I'm kidding? I'm not. It legitimately took me a real-life hour and a half to figure out how to get a turtle to build a platform out of dirt. Let's get into it. I start by collecting inputs for the length and width, at least after being briefly distracted by an apple and positioning the turtle on the edge of the coastline. After taking note of a feature I want to add later, I position myself on the bottom of the coast to avoid being seen by monsters. From here, the program is pretty simple. Add the turtle plays down a block, and if it can't do it, it cycles its selected inventory slot until it can. It turns at the end of each stripe of blocks, and repeats the process stripe by stripe until the whole platform is built. At least, that's what I thought would happen. I tested, and well, it tried. It just built in one stripe instead of turning and doing multiple. Seeing my predicament, a zombie offers his help in programming in exchange for some dinner, but I don't even have an apple to my name, so I can't host him. Instead, I encourage him to try fishing, which he embraces with gusto. With him sufficiently distracted, I begin debugging to try to find the issue. I figure I had better watch the turtle carefully while it makes its mistakes, so I position it accordingly and watch it place the exact same 3 blocks in a line once more. Clearly this was my fault, not a glitch. But what could be going wrong? I make sure the place down function returns Boolean values depending on its success, then make sure the inventory slot cycling happens in a loop, so the turtle doesn't skip any blocks. I tested again, and not only had I not fixed its original issues, I created a new one. The select function broke the program since it tried selecting slot 17 in the turtle's inventory, which doesn't exist. I adjust for this, ensuring the selected slot will never exceed 16, then tested a third time. This time, it did nothing except cycle infinitely through its inventory slots. This occurred since I instructed the turtle to keep cycling inventory slots if it can't place a block down, regardless of why the block is failing to place. I realize now that I had 2 instances of the turtle placing the block down, but only one was being checked for the while loop. This meant the turtle would place the block down successfully the first time, then loop endlessly because that placement wasn't accounted for in the while loop's condition. First, I empty the wood out of the turtle's inventory and test it again. As for why I thought this would change anything, I don't know. At the time, I still didn't understand my program's error, so I spent a while staring at it in complete confusion. I was even bewildered enough to resort to external resources to make sure the commands I'm using are doing what they're supposed to. However, this brief search availed me nothing, because everything was actually working exactly as it was supposed to, and I just couldn't see my duplicate instance of the place down command. Since I still have no idea this is happening, I resort to adding print statements to every segment of code I can. These statements don't change anything about the program itself. They are just a way for me to see what the turtle is doing as it's doing it, or at least what I think it's doing. Adding these statements made me think carefully about how the turtle detects whether it placed a block or not. To make it easier for me to see what's happening, I added a variable that keeps track of whether the turtle placed a block, which I called placed. Adding this leads me to my error, which is easily solved by updating the variable when a block is placed. After a few more print statements, I'm ready to try again. On what is now the 6th test, I get close. Very close. It goes 1 block too far in each stripe, and doesn't place a block on the last block it moves on. These problems should be easy fixes, right? As I brainstorm over the matter, another one of my undead neighbors pesters me. It's about sewing, of all things. Apparently she needed a new pincushion and couldn't find anything else soft enough in the forest nearby. She asked if I'd be willing to serve as one, which I declined. Why doesn't she go look for some sponges, I asked. Those grow underwater. She begins research but finds, much to both our surprise, that her old bones made a suitable enough pincushion despite their brittleness. I leave her to muse on her newfound discovery while I return to programming. At this point, I lose my patience and give myself an ultimatum. Unless I apply proper programming practices to every single step of my platform building process, it is never going to work as intended. To that end, I erase everything I had written thus far and start anew. This time, after narrowly dodging a conversation about politics from another one of my neighbors, I pull the ace from my metaphorical programming sleeve. User-defined functions. You see, I've introduced functions thus far as black boxes filled with commands. You call them by typing their names, and if needed, give them arguments to instruct them more specifically about what to do. Then, magically, you may end up getting some values in return. But what if you want your own black box? What if you want all of your code to be packaged up in a few neat little black boxes instead of it being written out in lengthy stanzas? Then user-defined functions are for you. In general, defining a function in any programming language just means making all three parts of the black box: specifying its input, running some commands with that input, then returning some values as output. The difference here is that you, the user, get to specify what commands are run in the middle. Here, I want to use user-defined functions to make my code easier for me to read and debug. Then maybe I can find the reason my program keeps having problems. Of course, I want to begin doing this immediately to organize my code, but before I can even write my first function for this project, I realize I need a new tool. A function that can identify items in the turtle's inventory. I thought I would use turtle.inspect for this, but what I really needed was turtle.getItemDetail, which inspects items in its inventory instead of blocks around it. I look up the appropriate function on the Computercraft wiki, then put it to work. My first change from the previous edition is to specify a list of blocks the turtle is allowed to place using table. In this case, it's just the garbage I have lying around, dirt and cobblestone. I want to write a function that places a block down for me, but realize that I need a function that ensures the correct inventory slot is selected each time the turtle places down a block. This is what I'll use both the list and the turtle.getItemDetail function for. However, my program becomes even more recursive when I realize that in order to make the slot preparation function, I need a function that cycles through inventory slots without exceeding 16. I write this briefly, then return to slot preparation. Except that I need yet another function. This one determines whether an item found in a turtle's inventory slot is the same one as one on the list of acceptable blocks to place. In the meantime, my acquaintance from earlier returns, inquiring about the public's awareness of the Great Pacific Garbage Patch, since its refuse just clogged his already useless throat with plastic. Since balancing the state of the economy with the state of the planet is a delicate issue, I inform him that I have to feed my pet rock and leave him to ponder ecology and economics on his own. Now that I can return to scripting, I finish writing my item checking function, then return once again to the slot preparation function. Since its component functions are complete, its routine is simple. The slot is prepared by inquiring what items are in the turtle's currently selected slot, and comparing that information to the list of blocks that are acceptable to place. If a match is found, the slot is prepared. Otherwise, the currently selected slot will be cycled until one is. After a few print statements to polish it up, I can return, at long last, to the block placing function. With all of its subsidiary functions built, its execution is also simple. The turtle checks to see if there is a block already below it. If there is one, it does nothing. Otherwise, it prepares a slot for placement, then places a block. That's all. Hopefully this is a good example of the power and beauty of user-defined functions. I took around 30 to 40 other lines of code and condensed them down into just 9. In turn, in the actual execution of the program, these 9 lines will become just 1 when I call the block placing function. Not only is it more compact and readable this way, but when the program inevitably goes wrong, I can debug it by modifying the function whose job it was to do the thing that went wrong. With so much time, space, and effort being saved by writing an individual function for each task in a program, there really is no reason not to write them. With the baseline functions complete, it's now time to rewrite the execution of my platform building program. Remember that every time I call one of my user-defined functions, it saves anywhere from 5 to 40 lines of code. As per usual now, I first collect input from the user. In this case, it's still just the length and width of the platform. Those numbers will be used to determine the length and the number of the stripes the turtle travels in, like before. With function calls, all I have to state now is that the turtle places a block with my user-defined block placing function and moves forward one step at a time. I will, however, need a function for turning around, so I write that as well. Turning the turtle around just means making it turn once, move forward, place a block underneath it, and turn again. Phantoms. Need I say any more? Their presence means I need to stop development momentarily to find shelter. Then I resume where I left off. After a change to a name, I realize that this is actually ready for testing. Before that, however, I need to craft some torches out of my charcoal. Now it's time for another test. It almost runs, but has a typo. I create a new one while fixing the old one, fix that, then try again. The shape it outputs isn't quite square, so I'm not sure what happened. I'll have to watch it more carefully next time. The second test of my new program shows me what's wrong. I told it to move the inputted number of blocks per stripe, which in this case was 3. However, the total length is actually 4, since I should have counted the block the turtle was sitting on at the start of each stripe. This is easy to adjust, as is the other issue. It turns around one too many times. These edits only take a couple of lines to fix. I test it one more time, and at long last I have my first success! The turtle really built a 3x3 platform. This is huge. Building platforms may seem mundane in normal Minecraft, but this feature alone would allow me to get a foothold in this world by building a base over the ocean. While landscapes with hills are beautiful and all, I need flat land if I'm going to build a base and farms to go with it. In particular, I want flat lands to make it easy for my next step, which will be automatically farming trees. Still excited from the first success moments ago, I tell it to build a bigger 8x8 platform. Unfortunately, a new issue arises that didn't happen during the first test. The computer doesn't understand what to do when it examines an empty slot in its inventory. This happens because of what getItemDetail returns when it sees an empty slot. Instead of returning a table, it actually just returns a nil value when it doesn't have an item to scan. This is problematic because my program assumes that getItemDetail would always return a table, and treated its output as such. When I realized this was the issue, it wasn't hard to fix. I just had to create a variable to store the inspected item's name and update it appropriately for either situation. However, I changed my mind about this and decided to make one last function for it instead. A function whose sole job it is to extract the name of the items, or lack thereof, of the selected inventory slot. Looking back at the footage, I realize I left an unnecessary variable there for the item's name. I'll have to remove that next episode. In the meantime, I tested the new edits, and lo and behold, it works. With that, there's only one thing left to do this episode. Place down a few torches. While my chats with my undead neighbors have been quite engaging and entertaining, I don't need them interrupting my work all the time. They don't like lights much, so a few torches should do to keep them away. I scroll through my code one more time just to see how many lines it took to write. Excluding the unnecessary variable declaration still left in there, it took 104 lines. So yes, because of how specific one has to be when telling computers what to do, it took an hour and a half and 104 lines of code to build an 8x8 dirt platform. This whole ordeal may seem silly when I could have made do at the time by simply micromanaging the turtle with one command at a time. The catch is this. Every time I write a program that lets the turtle successfully do something on its own, I've fully automated it. Experienced players will understand that this is a huge advantage over the vanilla or standard version of the game. In vanilla, automating tasks like building or farming items takes careful placement of redstone circuitry and often an in-depth knowledge of the game's source code to design. By scripting my turtle to do it instead, I can avoid the steep cost of all that infrastructure and the hassle of putting it together. Additionally, not all tasks are even automatable in vanilla to begin with. While building a platform out of dirt may be possible in the base game with a complicated enough setup, automatically building with other materials most certainly isn't. This is because there is no vanilla Minecraft feature that allows a machine to place blocks from its inventory. Only features from mods can do this. Those new to Minecraft in general may wonder why I'm interested in automatically having tasks to be completed in the first place. If all I'm doing is beating the Ender Dragon, shouldn't I be able to get there one command at a time? Perhaps. However, I'll be much more prepared if I have plenty of resources to build and fight with. In turn, I can obtain massive amounts of resources if I find a way to automatically acquire them while I'm away from my computer doing things in real life. This lets me play what I think are the more interesting parts of the game when I'm at my desk and lets me reserve all the tedium for the computer. Anyhow, that's enough chatter for now. I'm measurable by collapse, and this is how it took 104 lines of code to build this dirt platform. Peace.